Hello friends, here we have to prove that A operation B whole inverse equals B inverse operation A inverse. It is very important relation in group theory. How will prove that? Let's proceed. Proof. As we know from the definition of group that any element associated with inverse of itself gives identity elements. Therefore, we have AB whole inverse when it operated with AB gives identity element E. Now we will operate B inverse in both sides. Mind one thing that when you are operating any element in equality sign, then operate with same side. That is, when you are operating from right side, then operate with right side after equality sign. So we have to simplify it. AB whole inverse operation, by associative property we can change the order of the operation. Therefore we have A operation, B operation, B inverse operated together gives B inverse. Now we have AB whole inverse A operation as it gives identity element, so we have E here equals B inverse, implies AB whole inverse A operation E, that is A equals B inverse, implies that AB whole inverse. Now we have A here, so in order to remove it we will operate A inverse in both sides. A operation A inverse equals B inverse operation A inverse. As you can see that it gives identity elements, so we have AB whole inverse operation A operation A inverse gives identity element E, so we have equals B inverse operation A inverse, that gives AB whole inverse equals B inverse operation A inverse. It is the required result that we are seeking to prove. So we have AB whole inverse equals B inverse operation A inverse. It is very important relation in group theory, you must mind it. So we move on to the next class.